to take up homework on page 486 and 494. So I asked you to create a table or graphic organizer to describe the components of blood and their functions. So there I just want you to have, be able to tell me what do red blood cells do, what do white blood cells do, what do platelets do, and what does plasma do, okay? So that information's already been given to you. I'm just asking you to know what that is and to be able to work through it and be able to look at the table and recognize the differences between those different parts of blood. Question 2 says, how are erythrocytes different from other cells of the body? So the main difference for that is that you need to know that erythrocytes are enucleated, meaning they don't have a nucleus. So almost all cells, you'll learn as you go into biology, there are a couple other cells that don't have nuclei either, but your red blood cells are lacking a nucleus because if they had a nucleus, that nucleus takes up so much room they couldn't carry oxygen. And so they don't do much thinking. It's just a great big chemical reaction where hemoglobin and oxygen are attracted to each other, and then you form that oxyhemoglobin, which I'm going to get to in the future lesson. And red blood cells are designed just to be carrying something, okay? They don't have to think. It's just a total chemical reaction between two different chemicals. Question 4 says, describe the process of blood clotting. What is the risk associated with blood clotting? So I don't want you to think that platelets clot blood, so I did mention that to you. I want you to know that platelets are like the 911 call that goes out, and then you get thrombin and you get fibrogen coming in. And fibrogen is actually the material that makes the fibers that form that blood clot. So that's a good thing, but there can be risks associated with blood clotting, of course, because after some major surgeries, people sometimes get a blood clot, and the blood clot clots, obviously it's a blockage in the vein or the artery, usually in the vein. And if it blocks a vein, then you're not going to get enough circulation, and so that muscle tissue will not get enough oxygen, and so cells start to die and you could lose something, right? And then the other part of the problem with a blood clot is if you throw the clot, and when the clot becomes dislodged, it can enter the lungs, okay? It can enter the brain and cause a stroke, or it can enter the heart and cause a heart attack. So nothing for you guys to worry about, but I'm just answering the question for you. Question 4 says, describe the process. Okay, so I did that one with you. 5 says, what information is provided in a complete blood count, and how can that information be used? So if you've ever gone for blood work, your doctor will check off what she wants or he wants to see in that blood work. And sometimes they'll be checking for hemoglobin levels, right? So that you can check for hemoglobin levels, and the hemoglobin will tell you how much oxygen you're really carrying in your blood. If you have low hemoglobin, you tend to have low iron, and you need to boost that iron so that you can have more energy, because you can have more hemoglobin, which carries more oxygen. So what's in that blood count? The number of red blood cells, the number of white blood cells. They can check for platelets, and that's basically what they're checking for if you're checking a blood cell count. So how can that information be used? It can be used to determine whether you have different health issues. Okay, low platelets mean that you're not really clotting well enough. Low hemoglobin means you don't have enough energy because you're not attracting enough oxygen in those red blood cells. And then high or low white blood cells are indicating whether you have an infection, if you're fighting an infection. Sometimes in certain cancers, the white blood cell count goes through the roof. Okay, so white blood cells can tell us a lot of information as well. Question 6 says, emergency vehicles may carry O-negative blood for use at the scene of an accident. So why is that the case? And it's because O-negative blood does not have any antigens on it, okay? So it's lacking that Rh factor, and it's lacking the A or the B antigen. So in other words, O-negative blood can be given to anybody and they won't form a blood clot. They won't react to it. And so that's why on like New Year's Eve and New Year's Day, and sometimes after like July 1st, when they know that people are out partying and drinking and driving, unfortunately, and there are going to be some accidents, you'll hear Canadian Blood Services putting out a call for O-negative blood. They want to stockpile that because when you've got those emergencies, you can give that blood to anybody. It's like golden. And then create a table or use a graphic organizer, number 7, to summarize the compatibility of each ABO blood type and the rhesus factor. I did that with you, so review that in your notes. Who can give blood to whom? Okay, that's what we're asking there. And then on page 494, question 4, I really want to take this one up with you because you might have been stuck on this one. What type of blood vessel do you think this is? Okay, and so what they're showing us here, from what I can see, these are your red blood cells. Okay, and they're kind of squashed in there. Now, because they're squashed in there, and this is our vessel, that has to tell us that this is a small vessel. Okay, and if this is a small vessel, then that's got to be a capillary. because if you had an artery, you'd have lots and lots of red blood cells, tons of them, okay? And you have to say to yourself, okay, well, maybe these are the red blood cells, but they're not the red blood cells because in proportion, like a red blood cell wouldn't be that small compared to a white blood cell. And secondly, this is red. So this has to be a capillary. And then it says in question 5, why do you think the rate of blood flow decreases in the capillary networks? And it's because of this. It's because your red blood cells are so squashed in there, you can only fit like one beside the other. They're in line. All right. And so why is that? Now the question says, why is that an advantage? It really slows blood flow down. And why do you want blood flow slowed down? Because this here represents a cell. Okay, and what does this have? This is really red, so that means it's full of oxygen. And so the oxygen is going to have time to diffuse to this cell, and then the plasma could pick up the carbon dioxide. So why do we want our capillaries to be so small? Because it really slows down the flow of blood. And if the blood is moving slowly, it gives us a much better opportunity to pick up that oxygen from our red blood cells. All right, and then lastly, number 9 says, briefly describe the 2 primary functions of the lymphatic system. The lymphatic system is so important. It's a whole other system altogether that really doesn't get enough mention in high school, at least not in biology. Maybe it doesn't in healthcare. But if you have time and you think you're going into science, I would look that lymphatic system up because it's so important. You touched on it a little bit when we talked about white blood cells. You probably found that many of them are made there and what they do. 2 main purposes in terms of grade 11 biology. The lymphatic system removes excess fluid from tissue. So if you've got a lot of swelling going on, it's an indication that maybe the lymphatic system is not working as quickly as it needs to. And the lymphatic system would normally reduce swelling, okay? The other thing is it protects your body by filtering and destroying bacteria. So it produces certain types of lymphocytes, okay? And those lymphocytes are like little creatures, single-celled creatures that actually go and they attack bacteria and they attack viruses by eating them. So they're phagocytes. And so the theory goes like this. I don't know that you would have read this in the textbook. They believe that these guys are like endosymbiotic in our body. So in other words, we got these guys to live inside of us and they're just eating bacteria and viruses for us now. Okay, so kind of like an amoeba, right? An amoeba goes and it eats its food. These guys are very similar to that. And they're little creatures living inside of us, and they're white blood cells that just keep reproducing and fighting off our infection.